Okay, this is hypothesis testing using proportions, and also it's a different method. Instead of comparing P with alpha, we're going to compare Z critical factor with Z actual test statistic value. And that probably means nothing to you this very second, but it will hopefully by the end of this video. You are conducting a study to see if the proportion of men over the age of 50 regularly have their prostate examined is significantly less than 0.31. Okay, so the null hypothesis, remember from my last video, the null hypothesis always contains some type of equality. The null hypothesis and the alternative hypothesis never contains any type of equality. So less than 0.31, that means that it cannot be equal to 0.31. So the claim, that's the alternate hypothesis. The alternate, let's start with the alternate hypothesis. P is less than 0.31. That's the answers to the alternative hypothesis right here, which means the null hypothesis must be P is greater than or equal to 0.31. Okay, so if the claim is less than 0.31, that means that has to be an alternative hypothesis because it does not include 0.31. And I know it's a real fine line, but it's very important to identify that has to be in the alternate hypothesis because of the less than 0.31. That's why it's underlined there. So I always do whatever the claim is first, and that has to be in the alternative hypothesis. P is less than 0.31, which means the opposite is true um, of the null hypothesis, which is P is greater than or equal to 0.31. Okay, so those are the answers to the first ones here. Okay, all right, now we find the test statistic. Let's go over what we're doing first before we get into the nuts and bolts of this. I'm going to go to this screen here. This is different than what we did in the first video. For a left tail test, we're going to have a Z critical factor here. All right, and if the test statistic that we calculate is less than that Z critical factor, you reject the null hypothesis, okay? That's for left tail test. If that Z critical factor is to the right of, I mean, if the test statistic we calculate is to the right of the Z critical factor, then you fail to reject the null hypothesis, which is over here. For a right tail test, okay, we have a Z critical factor here. If that, so then we calculate the test statistic. For a right tail test, if the test statistic is greater than the Z critical number, then we reject the null hypothesis. If that test statistic is less than the critical number, which is in here, we fail to reject the null hypothesis. For a two-tailed test, what happened there? For a two-tailed test, you literally have two numbers. These are always going to be the same, and it's irrelevant in this problem, but I want to explain it to you for future problems. This number is always going to be the negative, and this one number is always going to be positive, same number. If the test statistic is calculated to be to the left of this negative number or to the right of the positive number, you reject the null hypothesis, as you see in the red. If it's in between, you fail to reject the null hypothesis. So Z critical factor less than, reject for left tail. Z critical factor greater than, reject null. Otherwise, fail to reject, otherwise fail to reject. Two-tailed test, either less than the negative number or bigger than the negative number, reject, reject. Anywhere in the middle, we say that it's going to be fail to reject. Okay, so that's what we're trying to do. We're trying to determine two numbers here. The Z critical number, and then after that, calculate the test statistic to see where it falls to the left or right. And also, again, we have to know whether it's a right tail, left tail, or two tail test every time, okay? So, um, all right, so in our problem, all right, so, and you're gonna have an Excel spreadsheet too, along with this video, you're just gonna plug in these numbers, okay? So, a sample of 720 men over the age of 50 found that 197 have their prostate regularly examined, okay? So I did you guys a favor. You can thank me later. And all you need to do is input the information, and everything you're going to need is going to spit out here for you. All right. You don't have to program anything. I did it all for you. All right. So let's see. let's 0.1 level of significance. So this is going to be 0.01. Okay, sample size was how much? How many samples? 720. 720. And how many said yes? And you could use this for future problems too, so make sure you don't screw up the calculations I did. 197. So 197 goes here. And what are they saying is the population proportion is 0.31. Okay, that's what's given in the problem. They say 0.31. There it is. Well, the Q doesn't really mean anything to you, but the sample proportion, in other words, 197 divided by 720, which is our sample proportion, that goes here. The test statistic is calculated, there's the formula if you're interested, is negative 2.112, and the Z critical factor is negative 2.32. So we forgot to mention earlier, is this a left tail, right tail, or two-tail test? Because obviously that's going to make a difference what we're looking at here, left tail, right tail, or two-tail. Remember from my prior video that a left tail test, the alternative hypothesis is less than a certain number, right tail greater than, alternative not equal to, okay? So again, going back to our problem, we know that the alternative hypothesis is right here, less than, so it's a left tail test. So yes, right here, there is a critical factor. So the critical factor is, let's see, what do they ask for first? Okay, the test statistic, they ask for that first. It doesn't matter, you could do either one of these first, but let's go in order of what they ask. Test statistic is based on the spreadsheet. The test statistic is negative 2.112, okay, and the critical value is negative 2.32. So let's not split hairs about the decimals. All we're looking at is which one is greater than this one or this one. Well, the test statistic, all right, so the Z critical, let's start with Z critical. Z critical is negative 2.3, okay? Z critical is negative 2.3, all right? What in the world is 1.5 doing here? Okay. Negative 2.3. All right, okay. Okay, this one, I'm not sure what that is, to be honest with you. Okay, I'm not sure what that, anyway. The Z critical factor is, the Z critical number is negative 2.3, okay? So that's here, negative 2.3, okay? That's the Z critical number. The actual test statistic is negative 2.1, so that's right here, okay? It's on this side of the Z critical number. And if I go back to this one, if it's on this side of the Z critical number, we fail to reject, all right? Okay, we fail to reject. Oh yeah, and then we have to go back to, so where is the claim? Okay, remember, the claim is in the null hypothesis because they're claiming it's less than 0.31. So, I mean, in the alternative hypothesis. The claim is in the alternative hypothesis, okay? All right, the claim is in the alternative hypothesis because that's up here less than 0.31, and remember less than has to go in the alternative hypothesis, and that's where the claim is. So the claim is in the alternative hypothesis, and they do not ask you where the claim is, but you absolutely have to know that in order to get this problem right, at least the last part. So we failed to reject the null hypothesis, okay? So the claim is in the alternative hypothesis, which either this one or this one, and we fail to reject. So it's this one. So this is the one right here that we're looking at for interpretation. If you just look at that, just the claim is the alternative, and we fail to reject the null hypothesis. So then the answer is there is not enough evidence to support the claim. And actually, that's exactly what this says for interpretation. There is not enough evidence to support the claim, okay? I hope that helped. This chapter can be challenging, I will admit that, and even for an instructor. So, all right, you guys, good luck.